Hey Mymy, look at what I just saw on Twitter. They're giving out free iron rings when you get a 90% on the APS360 final. Looks like it'll pay off to start studying.
Are you sure that's true?
Yeah, look, it was signed off by the Faculty of Engineering, University of Toronto. Seems pretty credible.
That's fake news, Ambrose. It's there to trick you into believing something.
That's horrible. Who can I trust? How do I know if what I read is true?
With the global nature of web-based interactions, we have all been exposed to fake news, since it is used as propaganda to mislead for political and social motives, and the task to verify the large amounts of information is only magnifying. My name is Mymy, we have Emily, Ambrose, and Fahim, and our group is here to present to you our fake news detector. We see machine learning as a tool to tackle this ever-growing problem of misinformation. The goal of our project is to combat fake news by identifying if a news article is factual in a more effective manner than that of humans. We'll go over data processing, our model, and also our test results.
We took two datasets from Kaggle, both of which contain news articles from various sources. Below is an example taken from one of our datasets. It contains a URL, a headline, the body of the article, and a label. A label of 1 means the article is real, and a 0 means it is fake. We combined both datasets into a large dataset of over 40,000 samples. In the end, we chose to use dataset 2, which had 4,000 data entries. Our reasoning will be discussed later in the presentation. Here is a roadmap of our data processing. After importing the data from Kaggle, we removed irrelevant columns of data such as URL and date. We then created CSV files to be easily uploaded into our projects. Using PyTorch, we pre-processed the text by removing non-alphanumeric characters in strings such as HTTPS. We finally split the datasets into training, validation, and test using a 60-20-20 split.
Now we'll be talking about the model. So some fast facts about the model. We had 100,000 different word embeddings. Our final layers, which I'll be talking about on the next slide, included embedding, a gated recurrent unit layer, an adaptive pooling layer with both max and average pooling, a dropout layer, and finally a linear layer. In our training, we altered the model architecture, such as the layers, as well as the batch size and learning rate. The final batch size was 32, and the final learning rate was 0.005. Now on the screen, you can see a figure of our final model. So the article was split into individual strings for each of the different words. This was fed into the embedding layer. We used an embedding layer with glove rather than a direct variable to allow for multiple simultaneous lookups. The embedding layer is then fed into the GRU layer. This is used because it's improved from the basic RNN, which already allows for context and sequencing to factor in decisions. And GRU also reduces the vanishing gradient problem, has some long short-term memory implementation to improve performance as well. So then we used adaptive, max, and average pooling. Adaptive pooling was used because there are variable input sentence lengths. So this adaptiveness eliminates the need to reconfigure the parameters such as stride for different input lengths. Now we use average and max pooling across all the different hidden state outputs of the GRU layer to reduce the possibility that we lose important information if we only had relied on the very last hidden layer. Unit outputs. So then the max pooling and average pooling are concatenated together and fed into the dropout layer, which is then used to reduce overfitting. Lastly, that is fed into a fully connected linear layer, which then predicts whether the article is real or fake.
Moving on to our demo. Using our model, we can quickly identify if the news article is real or fake. This is our collab, which can take one input text and then predict if it's real or fake. We have fake left. And we've input into our model and it predicts that it is 0, meaning that it is a fake news article, which we can manually confirm. For now, we are able to take one text input and receive a prediction. And to further extend this, we would feature this Python script to an abstraction via web server to accept dynamic input. Now on to results.
We tested our model on never seen before data using the test set of our 4K dataset and achieved an accuracy of 97.99%. This is very high compared to the baseline model which used random forest. It can be seen that AI is a suitable method to quickly and accurately classify fake news.
As a result of rigorous code implementation, testing, and hyperparameter tuning, we obtained the following results. Our training accuracy and validation accuracy reached just over 98%. And our training loss and validation loss are approximately 4% and 6% respectively. Further, confirming our model's effectiveness, we take a look at our confusion matrix. As we can see, our model has a very high rate of correct classification, as the number of false positives and false negatives are very small in comparison to the correctly guessed news articles. Our model was trained primarily on real left and fake right news data. So in order to test its effectiveness for as many cases as possible, we tested on the inverse to see if that still held true. We reached 75% accuracy in categorizing fake left-winged articles and 100% in accuracy in categorizing real right-winged articles. Keep in mind that we used a smaller sample outside of our data set to test these specific genres of news articles. To my left, we have a 10K sample data set that was thrown into our model and a 4K sample data set that was fed into our model. Now, what do you find strange about the models that are presented to us? The one on the right seems mostly normal, but the one on the left, it reaches a 95% accuracy within one epoch. Why is that so? Well, when we compare the two differently sized data sets, we realize that many articles from the same news source were found in the 10K sample data set, primarily being Reuters. And so what happened was the model memorized this classification for real news. The 4K sample data set, on the other hand, had a much more diverse data set where no particular news source was favored. As such, the accuracy gradually increased with each subsequent epoch. Thus, our model was tested most authentically using the 4K sample data set, which we used to show our quantitative results. Key takeaways include the following. The importance of a balanced, but also a diverse data set is crucial when testing for a fake news identifying model such as ours. Further, our model mainly trained with political news articles, meaning that the classification of political news articles being fake or real was prioritized. This meant that it did not specialize in the classification of other topics such as sports and entertainment news articles and as such. Thank you for tuning in, and we would love to answer any and all inquiries.